So today we're going to add a fourth rule to our exponent rules. I kind of think of this as raising powers to exponents, powers to powers. So the book calls it more multiplication properties of exponents. So our objective is going to be to simplify expressions that involve powers of powers. So before we move on, I put two little cartoons here just because algebra will be important to you later in life. When you're my age, you can use it to torture people your age. Or just a darn minute. Yesterday you said that x equals 2. Just a couple of algebra jokes for the start of the day. Okay, so what am I talking about? Powers to powers. So 2 squared is a power, and we're raising it again to another exponent. So you know what happens here. So I'm going to show you again, like I've started the other rules, I'm going to show you that 2 squared happening 1, 2, 3, 4 times. So 2 to the second. And remember that when we multiply common bases, we write the base and add the exponent. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So this would equal 2 to the 8th, which is 256. What you should notice is that this 8, we don't have to write the 2 to the second factor 4 times if we recognize that when we raise a power to a power, to get that new exponent, we write the base and simply multiply the 2 times the 4. We don't raise 2 to the 4th, that would be 16, but we take 2 times 4. So now let's take it up to a variable. So we're going to take m squared 3 times. So if we do that, there's 1 factor, 2 factors, 3 factors. Our old rule said that if we multiply a common base, we write the base and add the exponent. So that's what we're expecting to see. So what I'm encouraging you to see is instead of writing this out and using our old rule, we can develop a new rule that says if we have a power raised to an exponent, we multiply the 2 exponents. And that's our new rule. So I'm going to write this out, and then we're going to do some examples. I'm going to do some examples with you, and then I'm going to have some for you to do kind of at the end today. So this is chapter 8, section 4, if you need to be looking in the textbook. So we're going to really write 2 rules, power of a power property and power of a product property. So basically, we just talked about this one, that if you have a base raised to an exponent, raised to another exponent, you write the base and multiply the 2 exponents. We're going to take that further to say, what if we had, in parentheses, multiple things being multiplied? Then just realize that everything in the parentheses is going to be raised to that outside exponent. So the a is going to be raised to the m, and so is the b. I kind of like to think of this as you're distributing that exponent to everybody in the group. So everybody in the group is going to get that exponent. To find the power of a product, you found the power of each factor and multiply. These come a lot clearer the more examples we do. So here's the first one. This one I know you can do. If you take x to the third and raise it to the second, what would your simplification be of that one? And did you remember to multiply? So x to the third times x to the third is x to the sixth. You multiply the 3 times the 2. Number one mistake, of course, would be to put 5 there instead. Okay, on the next one, now we're going to start getting more complicated. And as we get more complicated, we're going to be using our rules from previous videos. So not only will we be raising our, using our power to a power that we're talking about today, we're going to see multiplication from the last rule. We're also going to see 0 exponents. We're also going to see negative exponents. So there's 4 possibilities here as we go through to kind of simplify. And sometimes you might be working with somebody and they choose to do it in a different order, but they get the same answer. Like I used this rule first and then this one, and you did it in reverse. It's okay. There's not sort of a set order, basically. All right. Now, having said that, you do have to worry about the fact that you would use your exponents before multiplying. So your PEMDAS, your order of operations, is still here. So when I look at this one, I'm not going to try to multiply the c to the 5th n because I've got an exponent here. So in this particular case, I do need to do that exponent rule. It's the e in PEMDAS. So I would start by getting c to the 8th. So I'd have c to the 5th times c to the 8th. And when I have c to the 5th times c to the 8th, I'm now back on our last rule that when we multiply common bases, we write the base and add the exponents. So that would be our final answer. And you're going to say, well, of course, I've got that. Here's the problem. When we were doing this rule by itself, you got in your head that you need to add these. We now have added a new rule that involves multiplication. And what can often happen is people's brains start mixing them up, and they get to this step and put c to the 40th. So please remember that when we're multiplying powers, we write the common base and add the exponents. And if we're raising a power to another exponent, we multiply the exponents. Okay, so let's take a look at the next one. So if we kind of get to the next one, I'm going to come out here because I see this exponent. You know, we're going to use the E in PEMDAS. We need to clean this up first. And if I have a power raised to an exponent, I would multiply. And I'd have m times g to the negative 5th. And you say, well, you're done. No, you're not. You're now going to go back to the very first video we did that talked about how to simplify an exponent that's negative. And you're going to take that and you're going to reciprocate it. You're going to move it to the other place and change it from a negative exponent to a positive exponent. So that's what I mean that you're now going to be using all 4 of your exponent rules. You're going to be using your negative, you're going to be using your multiplication, and the new 1 power. And what we haven't seen is the 0, that anything to the 0 power is 1. Okay, this looks like a colossal mess. So the first thing that I would do, I'm just going to use my screen, is just talk about cleaning this one up. And then once I clean that one up, I would put the screen up and just look to cleaning this one. Now this is where that second rule is going to come into play, that we've got a product raised to a power. So remember I said it's kind of like we're going to distribute this outside exponent to everybody in the group. So who's going to get to the 3rd power? The 4 is going to get the 3rd power. The a to the 2nd is going to get the 3rd power. And the b to the invisible 1 is going to get the 3rd power. Remember that both the 4 and the b have an invisible power of 1 here. So remember, we're going to take 4 to the 1st, raise it to the 3rd. A to the 2nd, raise it to the 3rd. B to the 1st, raise it to the 3rd. So 4 to the 3rd, A to the 6th, and B to the 3rd. And I've just cleaned this up. Number 1 mistake is to not give the 4 the exponent and just write 4 here and not have it be 4 to the 3rd. Now come over here and do this one. Everybody in the parentheses is going to get that 3. So A to the 1st is going to get the 3rd. So 1 times 3 is 3. And B to the 1st is going to get the 3rd. And now we've got this. Now we need to clean up. Can you clean this one up? So 4 to the 3rd, we can definitely simplify that to be 64. Now we have an a to the 6th and an a to the 3rd. When we multiply, we write the base and add the exponents. And b's, when we multiply, we write the base and add the exponents. And look how much cleaner that is than that mess. And, you know, if you were to say to me, Mrs. Werder, where do we use this? I have to sort of express to you how important it is when you get to higher math. And I'm just thinking of calculus right now. That if you were trying to do something called take a derivative of this mess, it would involve all kinds of rules. Whereas this one, now that it's cleaned up, that higher math is much easier to do on something like this than this mess. So you're basically cleaning up the house so that the tougher math is easier to do. Okay, the next one. Can you just right now simplify this guy? And did you get x to the negative 4? And now take the second group. Can you sort of do the power rule there? And did you write 3 to the 4th, x to the 4th, y to the 8th? Now we're going to look back to our other rules. Can you clean this up? So did you see 3 to the 4th? And oh, by the way, we're multiplying a common base of x. we add the exponents. Do you see the x to the 0 coming here? And since we're multiplying, and you're going to be multiplying by 1, he's going to disappear. And we're going to have 3 to the 4th, which is going to be 81. Oh, by the way, 3 to the 4th is the same thing as 9 squared. Or 3 times 3 is 9, times 3 is 27, times 3 is 81, y to the 8th. And because this guy is multiplying by 1, he disappears, because when you multiply by 1, it doesn't change your answer, your product. Look how clean that is compared to that gosh awful mess over there. Okay, before I have you do a few, we're going to do some scientific notation and some backwards problems, and then I'm just going to have you do a few on the video. So here comes scientific notation. Remember that when we're raising this to this power, this is just a multiplication. It's not really any different than looking, at this. It's a, b raised to that power. Well, here we've got 4.5 times 10 to the 5th raised to that power. So the 4.5 is going to get the power, and the 10 to the 5th is going to get the power. Does everybody understand what I just did? Again, I kind of think of it as distributing that exponent to everybody in the group. I'm going to pick up my calculator, and it is okay if you do the calculator for this. 4.5 to the 3rd. And I get 91.125. Remember not to multiply by 3. You should be raising it to the 3rd power. And I got times 10 to the 15th. Now let's go back to scientific notation and realize this is not improper scientific notation. So let's fix it. That decimal needs to be in between the 9 and the 1. So I'm going to move it there, and that would take kind of out a power of 10 here. And I need to compensate by putting it back into the end of the number, basically. And there would be my answer. Okay, so on this next one, this is multiplication and this is exponent. Again, we're going to do that exponent first. So everybody in the group is going to get squared. And the guy out in front is just the guy out in front. So we're going to have 3 squared and times 10 to the, don't forget, multiply. Be really careful. Don't put 64 and think it's a squared. You're multiplying. He's going to become a 9. He's going out in front. And when I multiply common bases, so take out this 3 squared, don't look at him right now, and see you've got a common base of 10, and when you're multiplying, you add exponents. Take a look at that for a second and make sure you understand where that came from. See where the 9 came from, and we would write the common base, add the exponents. And we don't have to fix it. It's already in proper scientific notation. So here's some of the backwards problems that I have to admit I really like. So can you tell me what would the exponent be in order for y to the negative 5th raised to that exponent would give you y to the 10th? And did you put negative 2? Because we would multiply these two to get a positive 10. So negative 5 times negative 2 would give you a positive 10. Okay, the next one, what exponent would go here so that this expression raised to it would give you simplify to this expression? And did you put to the 3rd? Because 2 to the 3rd would be 8, x to the 4th to the 3rd would be 12, and y to the 3rd would be y to the 9th. Okay, how about this one? Okay, so did you realize it has to be a negative in order to get it to go to the other place and reciprocate? And then the m to the 3rd became an m to the 9th, and did you see a negative 3? So it would be m to the negative 9th, n to the negative 6, and to get them to not be negative, you would reciprocate them to the other place and make them positive exponents. Okay, so, whoops, I went a little flying by. So here is kind of where I would like you to kind of do these. So the video is going to stop and walk you through these 4 to make sure that you're good, and then I'll come back and just double check. Okay, so on this one, you would have started by getting t to the 2nd times t to the negative 14th. And then you would add the common bases. So t to the 2nd and t to the negative 14th would give you t to the negative 12th. And then you'd reciprocate it, and it would become 1 over t to the 12th. The next one, you would multiply and get a to the 8th times a to the 10th. In common bases, you'd write the base and add the exponents, and you get a to the 18th. Number 1 here is be careful that you just didn't leave the 2. The 2 has to go to the 4th power as well. and 2 to the 4th would be 16, and z to the 4th would be z to the 4th. Everybody in the parentheses is going to get the power of 3. So 5 to the 3rd would be 125 times 10 to the 12th. Now the 125 needs to be fixed to become 1.25. You took away 2 powers of 10, so you need to go up 2 powers of 10, and you would get 1.2 times 10 to the 14th. So when you come into class, we will take a look at these a little bit more, and we'll do some, we'll do some practice and all that, go over everything you've done. So we have 4 rules at this point in time. We have exponent of 0, negative exponents, multiplying powers, and raising powers to an exponent. Can you guess what the last one is? Well, I'll tell you this much. It'll be on your next video. Have a great day, everybody.